Hey guys, welcome to day 56. Today we're looking at u substitution again, but today we're doing u substitution with definite integrals. A lot of it will be very similar to yesterday's video, or the last video we saw, with one pretty big difference. So let's take a look here at a u substitution with definite integrals. Okay, so here we have a problem. We're doing the integral from 0 to 1 of x times the quantity x squared plus 2 cubed dx. Now the beginning of this is going to start off the same, whether it's definite or indefinite. We need to choose a u, and we need to find du, adjust it if necessary, and go from there. Okay, so here's what we're going to do. When we look at this, hopefully you're getting better and better at choosing your u's. Again, I want to look for something, u, that's like the g, and then do the derivative, like its derivative shows up somewhere else, g prime in our chain rule. So I want u to be x squared plus 2 here. Because then my du will be 2x dx. Now 2x dx is not in my integral here, but I do have x dx. So I want to make an adjustment to my du by multiplying both sides by a half. And it's just like what you did yesterday on your homework. Okay, the only difference comes in our setup now. I'm going to start setting it up the same. I'm going to put my half out front. I'm going to rewrite this integral. I'm going to put my half out front. And I'm going to put my du at the back. Half du is substituting out our x and our dx. If you notice, I did not copy 0 and 1 down, because those are going to be changing. Okay? I'll put the limits on my integral here in a second. But for right now, I'm doing everything like I did yesterday. Now that x squared plus 2 is going to be a u. The only thing that was never accounted for was that 3. Right? This 3 was never accounted for in here. So it has to transfer over. And so far, everything is exactly how we have done it before. Okay, what comes in different now is we need to adjust our limits of integration. Okay, we want to rewrite this problem entirely to be in terms of u, and we can just solve it and get a numerical answer. That's correct. So here's how I adjust it. The 0 down here is in reference to x. Okay, so here x is equaling 0. And here x was equaling 1. What I want to do is figure out what they would equal in terms of u. So I'm going to take that 0, I'm going to plug it in for x. 0 squared is 0. 0 plus 2 is 2. So my new bottom limit of integration is going to be 2. Right? And again, I got that by doing 0 squared plus 2. Similarly, I want to use this 1 and plug it in. And 1 squared plus 2. 1 squared is 1, 1 plus 2 is 3. So my upper limit of integration is a 3. Now the nice thing, right, that's the big thing that we have to remember. We have to adjust those numbers on the bottom and the top of the integral sign. Once we adjust them, the nice thing is we now never have to go back to x ever again. Okay, now we can just solve this integral. This integral is exactly the same as the original integral I wrote. So now I just have to do my definite integral like we know from before. So the definite integral, I'm going to use my brackets. The antiderivative of u cubed is u to the fourth. I divide by 4 to get my 1/4. And again, I've got my 2 on the bottom now and my 3 on top. Those numbers have changed from before. Now to solve this, I can make this a little bit easier. I can take that 1/4 and throw it out front with the 1/2. And I'm going to have 1/8 Okay. Now all I have to do is plug in the top number, 3 to the 4th, and subtract the bottom number plugged in, 2 to the 4th. Now you just have to figure out what 3 to the 4th is. I know 3 cubed is 27. 27 times 3 is 81. So I get 1/8 of 81 minus 2 cubed is 8 times another 2 is 16. (81 minus 16), I'll do that up here. 11 minus 6 is 5. I get 65. So my final answer is 65/8. Now, if I go to my handy dandy calculator here, let me just get it back in radians for later. And I type in that original integral, it was math 9, integral 0 to 1 of x, parenthesis, x squared plus 2 cubed dx. And I get that answer. Change it to a fraction. I see that I was right. My answer is 65/8. So again, what's different here? Starts off the same. Choose your u. Choose your u. Find your du. Adjust your du. The only thing that was really different here was I had to change these two numbers. And I get those numbers by plugging the top and the bottom in for x. And I just have to solve the definite integral like we're used to from before. Okay, let me show you another example. Okay. We saw an indefinite similar to this on our last homework, but we haven't seen a definite integral like this yet. So let's talk about it. Again, when I take a look at this setup here, what I notice is 16 minus x squared, right? The derivative of that would be negative 2x dx, and that's similar to what I have on top, x dx. So I'm going to choose my u to be 16 minus x squared. Notice I did not include the square root. I did not include the square root because the derivative, when I keep the square root, becomes much more difficult, right? And it doesn't show up in that problem. So I'm just going to let u simply be 16 minus x squared. That square root will carry over to my rewritten integral. Du then, here's where we need to be careful with this negative, right? My du is negative 2x dx. And I need to make it match x dx. So I'm going to do that with a negative half. It's going to equal x dx. Again, I'm just going to rewrite this integral. I'll put my negative half up front. I'll put my du at the back. That's taking care of the x and the dx. Okay. That 16 minus x squared is two things. It's in the denominator. So I'm going to put my u in the denominator. But it's also under a square root. So I have to make sure that this square root transfers over. I just have a 1 as a placeholder on top. Now what I have to do now is adjust my limits of integration. So I'm going to take 0 and plug it in down here. 16 minus 0 squared. 0 squared is 0. 16 minus 0 is 16. Root 12 squared is 12. 16 minus 12. Okay, just plugging it in here. 16 minus 12 is 4. Now you might notice, hey, I got a bigger number on bottom and a smaller number on top. You're certainly welcome to, if you want, to switch those and put 4 on the bottom and 16 on top. If you do that, then just make sure you switch that negative half to a positive half. Okay? But I'm just gonna keep it going because we don't need to do that. Again, here's what I have. I have negative half. I'm going to rewrite this. Again, I made it an easier integral. It's still not a super easy integral. That square root u I'm going to write as u to the half, but it's also in the denominator, so when I move it up, it becomes u to the negative half. Okay. And again, now I'm ready to bump and divide. So I'm going to get my negative half. I have to bump the power up by 1 and then divide by half. Well, I'm going to take 1 divided by half, but I'm really thinking of that as 1 times the reciprocal, 2. 1 times 2 is 2. On the bottom, 4 on top. Again, I'm going to take this 2 and move it out front. 2 times a negative half is a negative 1. Okay. And I know u to the half means square root, so I just have square root 4 minus square root 16. The square root of 4 is 2. The square root of 16 is 4. So I have negative 1 times 2 minus 4. 2 minus 4 is negative 2. Negative 1 times negative 2 is positive 2. So all that work to get a really simple, nice answer of 2. Again, let's take a look at the calculator and make sure that that's correct. Do math 9, integral 0 to root 12. And my function was x over the square root of 16 minus x squared dx. Oops. And it spits out that correct answer of 2. All right, I think I'm going to cut the video there. A nice short one for tomorrow. Talk to you guys later. 2 chains. Bye.